Hello, my name is Suhasini Sharma. I'll be presenting you a video on our project titled Automatic Traffic Density Control and Alternate Routing System, which is guided by Professor Mahita B., Assistant Professor, Department of Electronics and Communication Engineering, Sambram Institute of Technology. We are a team of 4 members, namely Charan J., Hemant, Praveen Kumar C., and Suhasini Sharma. The large increase in traffic density during the last few years has required the automation of some functions of traffic control and monitoring. As the automobiles are increasing day by day, controlling of traffic has become hectic. The existing system involves image processing and smart data analysis, which work according to the time delay. Traffic congestion is a condition on transport network that occurs as the use increases and is characterized by slower speeds and increased vehicular queuing. The most common example is physical use of road today by the vehicles. When traffic demand is more, the interaction between vehicles slows the speed of traffic flow and thus results in some congestion. Here are few examples of traffic congestion being encountered in India. Physical use of road today by the vehicles. A study says our country loses almost rupees 60,000 crore per year due to traffic congestion, including fuel wastage, slow speed of freight vehicles, and waiting time at toll plazas and checking points. A study on operational efficiencies of freight transportation by roads has claimed there are many problems and losses faced due to congestion, such as fuel loss, loss of pay for employees for not reaching in time, time loss for passengers, loss of life for not reaching hospitals in time, air pollution, and increased road accidents due to overspeed taken up to make up the lost time. Henceforth, we look forward in providing an effective solution through the project. Here are few examples of how emergency vehicles are being stuck in traffic jam due to congestion. The main objectives of our project are sensing the density of vehicles present in all lanes, to implement ultrasonic sensors at certain distances from the signaling unit. Thus, we aim to create a potential and cost-effective service, to provide alternative routing through IoT by sending the data to cloud, where the data gets collected through Node MCU and is displayed through OLED display. The main objective is providing free way to emergency vehicles. Here is a proposed system using which our prototype is being built. Here's a demo on traffic density control system. This is our working prototype, which consists of light emitting diodes. These LEDs are in turn connected to the microcontroller. Microcontroller here controls the entire working of the prototype. Microcontrollers are connected to the ultrasonic sensors placed in all the lanes at certain distance from the signal poles. Microcontroller, once turned on, is connected to MQTT and Wi-Fi module. The signal lights are turned on and particular lane traffic density is sensed, and traffic lights are incremented according to that. Ultrasonic sensors are being placed on all the lanes at few distance from the traffic signal poles, so that number of vehicles entering the lane is estimated and data is given to microcontroller to adjust the timer. Depending on the density of the vehicles in particular lane, the data is sent to microcontroller, which in turn adjusts the timer whether to be incremented or not. Here the first sensor is placed to analyze the traffic density, and the second sensor is used for alternate routing, as well as an RFID tag and reader are used for emergency vehicles. Here is a demo on providing free way for emergency vehicles. The RFID tag is placed on the emergency vehicle and reader is placed on the road surface. So when both the reader and tag come in contact, the signal flow is incremented for that particular lane where the emergency vehicle is coming, and the signal lane remains free until the emergency vehicle passes out of that particular lane, and all other lanes will not be given the flow time. Here is a demo on alternate routing system. When there is excess traffic in multiple lanes, using Internet of Things, we display an alternate route for the vehicles to avoid the traffic jam. An OLED display is placed on the previous junction. Using the sensor values, the microcontroller sends a signal to the Node MCU, which is an open source IoT platform, using an external Wi-Fi module. This Node MCU, which is in turn interfaced with the OLED display, displays the message whether the traffic is low or high. If the traffic is high, it requests the vehicles to take an alternate route. Here's the simulation for the serial monitor. All the sensor values are displayed. It scans the Wi-Fi network and gets access to it. The MQTT is also connected, and then the sensor values are read. After reading the values, the traffic density is analyzed and the signaling time is incremented according to it. If no traffic is there, an initial 10-second delay is given, and if traffic is encountered, then the signal time gets incremented. So another 5 seconds is provided for the traffic high lane, and a total of 15 seconds is provided for the traffic high encountered lane. The process is repeated for all the lanes respectively. This is the serial monitor which is displaying the sensor values. It is stating that lane 1 does not have traffic. Here, when flow time is provided for a particular lane, the traffic density is being measured for the successive lane. Since we can't depend on automation during emergency situations, we make use of alternate manual control present at the signaling unit. Hence, the project is set to seek the answer for at least some amount of reduce in traffic jam and leading way for emergency vehicles. The hardware used are Genio Mega 2560 used to control the traffic working, which is designed for projects that require more input-output lines. It consists of 54 digital input-output pins and a 16 MHz crystal oscillator, HCSR04 ultrasonic sensor. These are transducers that converts ultrasonic waves to electrical sounds. They consist of 4 pins, and LEDs are placed in the signaling unit. Analog switches are used for changing the mode of operation of the signaling unit. LEDs are used as traffic lights here. Raspberry Pi 3 Model B is used as a server in this project to store the sensor data. It is a computer that is on the chip. NodeMCU is an open source IoT platform for publishing the data through OLED display. It consists of a firmware that runs on ESP8266. In the previous junction, we have placed an OLED display. The emitting colors are OLED and yellow. They are thinner, lighter and more flexible than other LED and LCD displays. This OLED display is interfaced with the node MCU. Hence, any traffic high or low message is being displayed here. An RFID reader is placed on the road surface and a tag is placed in the emergency vehicle. This module directly connects to any microcontroller UART or through RS325 converter to PC. The next component is Wi-Fi module, ESP8266. It is used to communicate with cloud to upload the data. It has 32-bit RISC CPU, 64 kilobit of instruction RAM and 96 KB of data RAM, 16 GPIO pins. The softwares that we have used are Arduino, Raspbian OS and Python for programming. Finally, we conclude that in this system, traffic density is analyzed on all the lanes, and depending on the density of the traffic sensed in particular lanes, the flow time is incremented accordingly. Hence, when free lanes are detected, the vehicle user can be set to go without waiting. This system also provides freeway for emergency vehicles, where RFID modules are involved. Also, this model suggests alternate route for the vehicle user, which employs Internet of Things. If this approach isn't satisfied by the user, then the user can switch to manual approach through the switches placed at the signaling unit. Some of the advantages of the proposed system are freeway traffic for emergency vehicles, reduction in waiting time of vehicles at the traffic signals, and unmanned service. The disadvantages of the proposed system are when all the lanes have high vehicular density, the timer becomes constant for all the lanes. And the applications are it has a real-time application and can be implemented in current traffic system. Thank you.